Section 8.1, Factoring Trinomials and Difference of Squares. So the very first part of this section, why do we need to factor? So graph the following quadratic function using your TI-83 or TI-84 calculator. So we're going to put in this quadratic equation. So we're going to start by pushing y equals to get into our graphing screen, and then we're going to push the button that looks like this to type in x squared plus 2, and again pushing this button again to get another x, subtract, and 1/5 for 15. And then we're going to push zoom 6 to put our calculator back to the standard window initially to change anything that we may have done on a prior problem, and then zoom 0. Okay, so that key punch will set the x range to go from -10 to 10, and then zoom 0, it will figure out what it needs to set the y min and y max at to capture the graph between -10 and 10. Okay. So we can see that we've got this parabola type shape that we saw in the last section. So for any graph, some points of interest are its x-intercepts and its y-intercepts, which we first saw back when we were looking at linear equations. Okay, so for a linear equation, when we had kind of a slanty line, so if we had our plane and somewhere we had some sort of slanty line, it would cross each one of these axes in exactly one place. Okay, but now with a curve, we can see that we have one place where it crosses our y-axis, but we have two places where it crosses the x-axis. So from before, what do the coordinates of a y-intercept look like? Well, a y-intercept is the value of y when all the other variables are zeroed out. So in this case, our only other variable is x. So they'll have this form. So we would need to solve the following equation for y. So if this point is on the graph, then it has to satisfy the equation. So again, we're going to take our starting equation and we're going to put parentheses around just the variable before we substitute a value. So we're going to get y equals parentheses 0 parentheses squared plus 2 parentheses 0 parentheses minus 15. Okay. So 0 squared is 0, and 2 times 0 is 0, and take away 15, we'd get a -15. Okay. So if we put together that information, our y-intercept is at the point 0, -15. So we plugged in a 0 for x, and for the output we got -15. So down here, that point is at 0, -15. Okay. Now, what do the coordinates of an x-intercept look like? Well, the coordinates of an x-intercept is where it crosses the x-axis, and again, all other variables will be 0. In this case, the only other variable is y. So they'll look like this. So in this case, we're going to put in for y a 0. So if we take our equation that we started with, we would get 0 equals x squared plus 2x minus 15. Okay. Well, this equation is not as easy in its present form to see immediately what values of x will make this true. Okay. So let's look at the graph above. Where does it look like the graph crosses the x-axis? So if we're looking at our graph that we had, okay, so again, this axis has been changed and doesn't run from -10 to 10 when we push zoom 0. Okay, but the zoom 6 feature, these still do run from -10 to 10. And so in here, each one of these tick marks is 1 unit away. Okay, so it looks like we have an x-intercept back here at -1, 2, 3, 4, 5. And it looks like we have another one at 1, 2, 3, 0. Okay, so it looks like we have x-intercepts at the point -5, 0, and 3, 0. But again, if that point is really on the graph of this equation, then it has to make that equation true. Okay. So we can check that mathematically to prove to ourselves it really does or does not fall on the graph of that equation. And so again, before we substitute for x, we're going to put parentheses around just the variable, and keep in mind that this is x and y. So for y, we're going to substitute 0. And for x, we're going to substitute -5, and these parentheses are extremely important. Okay, without them, we don't get the right answer. So negative 5 times negative 5 is a positive 25. Positive 2 times negative 5. So we're going to subtract 10 and subtract 15. Okay, and so we get 0 equals 0, which is true. Okay, so we do know that negative 5, 0 makes the equation true. Okay, but what about the other point? So again, I'm going to put parentheses around x before I substitute. So 0 equals 3 squared plus 2 times 3 minus 15. So 3 times 3 is 9. 2 times 3 is 6. So we get 9 plus 6, which is 15. Take away 15, which is 0. So 0 equals 0, again, is a true statement. Okay, so this ordered pair made the equation true. Therefore, this point is on the graph of this equation. All right, so these 2 points make the equation true. So these 2 points, negative 5, 0, and 3, 0, are solutions to that equation. And so these points have to be on the graph of that equation. Okay, so since these points are part of the graph, and they do fall on the x-axis because they have a y-coordinate of 0, these points are the x-intercepts of the graph of y equals x squared plus 2x minus 15. Now, how do we go about finding these x-intercepts without looking at a graph on the calculator? And what about graphs that would have x-intercept at something like the square root of 5, 0, which we would never be able to guess exactly by looking at a graph on a computer or a calculator? So in this section, we're going to start building the skills necessary to solve another type of equation. We've spent a lot of time solving linear equations, and now we're going to look at solving quadratic equations in one variable. Okay, so what does a quadratic equation in one variable look like? When we looked at quadratic expressions and quadratic functions, so a quadratic equation is just an equation that can be written in the form ax squared plus bx plus c equal to 0. Again, where a can't be 0. For it to be quadratic, it has to have the x squared term, and again, x terms and constant terms are optional. So again, a quadratic equation in one variable. So our one variable here is x. Doesn't always have to be. Sometimes context problems that might be t for time or something, but again, on your calculators we look at things, the input variable it will take is x. So we've got ax squared plus bx plus c equals 0. Okay, well, this looks an awful lot like the form we had up here. Okay. So again, in trying to find where the x-intercepts were for that particular graph, it involved solving a quadratic equation that was of this form. So we're going to look at two different methods in this particular class for solving quadratic equations in one variable. So we're going to start with the factoring method, and then we're going to also look at something called the quadratic formula.